Modal analysis. Modal analysis is the study of dynamic properties of the structure. The primary modal analysis outputs include the structural time period and the mode shapes. Each mode shape corresponds to a specific time period. Modal analysis utilizes the structural mass and stiffness to compute the mentioned outputs. What are mode shapes and how is time period related? As mentioned, each mode shape has specific time period. Consider a 3-story frame as shown. The result of modal analysis performed on this 2-dimensional structure would be 3 mode shapes and hence 3 corresponding time periods to those mode shapes. Let's call the first mode time period as T1, second mode as T2 and third mode as T3. It is clear that time period of the first mode will be greater than second and hence time period for mode 2 will be greater than time period for third mode. As in first mode, all masses displace or rotate in same direction, hence higher displacements and therefore higher time period. Similarly for second mode and so on. For 3-dimensional structures, each story corresponds to 3 modes per story, considering displacement modes only. The modal analysis is also important to determine the mass participating ratio in a particular mode. Most of the international codes such as IBC, ASCE require us to consider at least those modes in analysis and design having a mass participation of 90%. Buildings with symmetrical shape, stiffness and mass distribution with vertical continuity and uniformity behave in a fairly predictable manner. A 2-dimensional model is generally sufficient. Whereas when buildings are eccentric or have areas of discontinuity or irregularity, the behavioral characteristics are very complex. For moderate to high-rise buildings, the effects of the higher modes may be significant. For dynamic analysis, Ritz vectors are recommended over eigenvectors because of the same number of modes. Ritz vectors provide a better participation factor which enables the analysis to run faster with the same level of accuracy. Let's have a look on how to perform the modal analysis in ETABS. We are using in previous lectures the structure is 20-story structures. In the last lecture we defined the P delta analysis. Let's define with the modal analysis case. We go to define modal cases. Here we have by default defined modal eigen. As already discussed, you can use the Ritz analysis method if the structure is complex or irregular. While we will be going with the default option. Since the structure is 3D, hence the number of displacement modes for the structure would be 3 times the number of masses, or for this structure it is a simple residential structure, so 3 into the number of stories. Since it is a 20-story structure, so we have 60 modes, that is maximum, and click on OK. While an important option is we have to use the P delta settings as well, which we defined in the lecture number 22. Now we go to analyze option and click on set load cases to run. The action is set to be run and click on run analysis. So our analysis is complete. Let's click on the deform shape of the structure. So the scale factor has been specified a little high, so that's why the deform shape was totally distorted. Let's click on mode and set it to automatic. We are going to see the displacement or deform shape for the first mode. So first mode, apparently the structure is twisting about z-axis. So the first mode is a rotational mode. We can also see the animation. So after looking at the animation, we are sure that the structure's first mode is rotational mode. You can also see the time period of the structure in this mode, that is first mode is 2.526. Similarly, you can see for the second mode and third mode and so on. Let's have a look at the second mode. In second mode, the structure appears to be displacing in x direction. So you can also see the animation for this, and similarly for the third mode. These are the axes. And for the third mode, the structure appears to be displacing maximum in y direction. Let's have a detailed look on the analysis results from the modal analysis. We go to analysis and then results, and then we click on modal analysis. We'll be seeing 5 tables for the modal analysis. The first table is the modal direction factors. The modal direction factor shows us the time period and the displacement corresponding to the number of mode. For first mode, we have a time period of 2.5 seconds, second mode 2.46 seconds, third mode, and so on. Modal load participation factor, this should be 100 or at least 95% if the structural modeling is correct. Modal participation ratio, it is one of the most important tables to discuss. Let's say for the first mode, I need to be sure that what was the mode in which the rotation is occurring. So for first mode, I am only getting displacement of 11% in x direction, 0% in y and z direction, while I am getting a rotation about z axis of 69%. So the first mode, we have the highest number of 69% in rotation about z axis, and that is what we saw in the deformed shape. For the second mode, we are getting 56% displacement in x direction, 0 in y, and 14.7% rotation about z axis. So the second mode is a displacement mode with a period of 2.47 or 2.469 seconds in x direction. For the third mode, we are getting a displacement mass participating in y direction corresponding to 68% mass of the building, having period of 2.44 seconds, displacing in y direction, 0 in x direction, and 0 in rotation about z direction. Similarly, we have to go till at least 90% of some ux, some uy, we have to enter the modes of at least 90% of all these participation masses. So we are not getting some Rx and some Ry. At reaching 11th mode, we are getting above 90% in some Ux, some Uy, and some Rz, but not for some Rx and some Ry. So we may go ahead and select a higher number of mode. So mode number 20, as I think, is satisfying the requirements of at least 90% mass participation. Still we are having 88% in RY. So I think mode number 21 will satisfy it. Yes, mode number 21 is satisfying with a sum of translation in X direction of 97% mass, sum of translation corresponding to displacement in Y direction of 97.6%, some Rx, some Ry, and some Rz. You can also neglect some Rx and some Ry. However, the important thing here is some Rz, some Ux, and some Uy. So for explanation purposes, we have 21 important modes. If you want to speed up the analysis and reduce the time consumed in analysis, so you can enter the number of modes as 21 here, and next time you will perform the analysis, you will enter a 21 mode analysis, so it will take less time to